Welcome to this explainer. Okay, today we are going on a bit of a mathematical journey, building the entire universe of numbers completely from the ground up. We're going to start with the absolute basics, integers, and build our way up to the grand unifying theory of rational numbers. So, if you're looking to literally master your Form 1 math foundations, you are in the exact right place. Let's get right into it.
So here's our agenda for today. We'll be hitting 5 key areas. First, the integer family, then arithmetic rules and laws, followed by navigating fractions and decimals. After that, we dive into the world of rational numbers, and finally, mastering combined operations.
All right, kicking things off with Section 1, the integer family. Let's meet the core building blocks of our whole math universe.
So what exactly is an integer? Well, simply put, integers are whole numbers. Think of numbers like a positive 15, 0, or even a really large negative number like negative 2,399. But honestly, what's just as important is what they don't include. There are absolutely no fractions and no decimals in the integer family. Things like 0.88 or a half, yeah, they are strictly left out of the club.
Now, let's talk about the number line illusion. It's a concept we honestly take for granted all the time, but the logic is pretty fascinating. The further right you go, the greater the value. 3 is greater than 0, right? But the further left you go, deep into the negatives, the smaller the value gets. So that means a big-looking number like negative 36 actually holds way less value than a negative 6, just because it's further to the left. Makes sense, right? Moving on to Section 2, arithmetic rules and laws. Now that we've got our building blocks, we need to learn the laws of physics that actually govern them.
Okay, if you remember just one thing from today, you need to memorize this golden rule of thumb for adding, subtracting, multiplying, and dividing. It's a real lifesaver. Same signs give a positive result, and different signs give a negative. Simple as that. For example, multiply a negative 5 and a negative 4. Those same negative signs combine to give you a positive 20. But divide a positive 6 by a negative 2? Those different signs leave you with a negative 3. Master this, and I promise you'll avoid the most common exam mistakes.
And that brings us to the 4 laws of arithmetic. You might want to take a mental screenshot of these laws, honestly, because they'll make your calculations so much faster. First, the commutative law just means a plus b is the exact same as b plus a. The order doesn't matter. Next, the associative law shows that how you group numbers doesn't change the outcome. Then the distributive law lets you smoothly distribute a multiplication right across numbers inside a bracket. And finally, the identity law just proves that adding 0 or multiplying by 1 keeps a number's original identity perfectly intact. Basically, it stays exactly the same.
All right, Section 3, navigating fractions and decimals. Let's expand our universe and look at the spaces between those whole numbers.
So, a fraction is essentially just a numerical quantity made up of a numerator divided by a denominator. Instead of whole numbers, fractions give us specific little pieces of a whole. And, much like integers, positive fractions are quantities greater than 0, while negative fractions are quantities less than 0.
But how do we actually compare these pieces? Well, that's exactly why we need common denominators. It just makes comparing them an absolute breeze. It's really just 3 logical steps. Step 1. Multiply the top and bottom so the denominators are exactly the same, like turning 1/2 into 2/4. Step 2. Now that the bases match, you just compare the newly adjusted numerators. And step 3, plot them left to right on a number line. Boom, perfectly mapped out.
And you know what? Decimals follow that exact same logic. Positives are always greater than 0, sitting happily on the right. Negatives are always less than 0, stretching out to the left. Once you've got that integer number line down, decimals just naturally fill in the gaps.
Which brings us to Section 4, the world of rational numbers. We've got our integers, our fractions, and decimals. Now it's time for the grand unifying theory.
The core definition of a rational number is absolutely crucial. If you can write a number as a fraction, which we represent as p over q, where both p and q are integers, and that bottom number, q, is not 0, then it's officially a rational number. This one little p over q formula literally brings the whole number universe together.
Now, that definition brings up a kind of fascinating question about those integer building blocks we talked about earlier. Based on that p over q rule, is a negative whole integer, like negative 9, actually considered a rational number? Think about that for a second.
The answer, absolutely yes, it totally is. Because an integer like negative 9 can simply be written as a fraction, negative 9 over 1. The p is negative 9,
and the q is 1. And since 1 definitely isn't 0, it effortlessly fits our rational number rule. Pretty cool, right?
Okay, final stretch. Section 5, Mastering Combined Math Operations. Let's take all these rules we've learned and actually put them to the test.
To avoid total cognitive overload when you're staring down a huge equation, you have to follow this priority order. BODMAS. Step 1. Calculate the brackets first, always. Step 2. Hit the multiplication and division, moving strictly left to right. And Step 3. Finish with addition and subtraction, again, scanning left to right. Seriously, this priority list is your ultimate mathematical compass when exam pressure hits.
All right, let's put it into practice with an intimidating expression straight from the source material. We need to solve -12 plus -16 divided by -22 minus -24. Wow, okay. At first glance, that is just an absolute mess of negative signs.
But hey, if we just isolate the steps and trust our sign rules, we've got this. Step 1, resolve the top bracket. A positive and a negative make a negative, so -12 minus 16 is -28. Step 2, the bottom bracket. Two negatives make a positive, so -22 plus 24 is just 2. Step 3, we simply divide -28 by 2. Different signs mean a negative result, so we get -14. Just by trusting the process, we took that massive, complicated fraction and reduced it down to a clean -14. Easy.
So, as we wrap up this explainer, remember your key takeaways for your exams. Always double-check those signs, religiously follow BODMAS, and remember that every whole number is a rational number. But before we go, I want to leave you with one provocative thought. We know a rational number has to be written as p over q, and we hammered home that q cannot be 0, but what actually happens to the mathematical universe if q is exactly 0? I mean, what does it truly mean to divide something into 0 parts? I'll let you ponder that little mathematical mystery as you continue your studies. Thanks so much for learning with me today.